Well, in Lab 1, we had walked through the process of accepting an assignment off of Canvas that will clone a repository into the GitHub Classroom, and then you can take that GitHub Classroom repository and clone that into your workspace through VS Code. All right, and so from there, we went to Box and went to Vivado and ran all the Verilog stuff from Vivado. I do want you to know how to take a look at things in VS Code, all right? Because like we'd mentioned in the lab last time, it's a light version that lets you run from your home computer. Uh, it's pretty straightforward to use, and it's also an IDE that's used for lots of other applications. So it's good to know what to see when you use something like VS Code. All right, so let's take a look and run through the workflow. So let's assume that you've cloned the repository that I gave you for Lab 2, and what you see is right here, follow my mouse, right here is the file structure. Okay, so we can take a look at this. RTL is where the design files are, and so I have the four logic functions that we're gonna be implementing. I have the hex decoder, I have the top, the wrapper, and the 7-segment driver. Those are the design files, okay? There's no printing in a design, it's a circuit. So to test this, you would need test benches, and so we have test benches associated with most of these files. We'd use some of the others from the previous lab, so no need to test them again, okay? So there's the test benches, all right? When you run simulations, things will show up in the waveform directory. Nothing's there right now because we haven't done anything. All right, so another thing that's important for you to use when you use VS Code is the make file. The run buttons over here won't work with Verilog because Verilog is running an open source way of compiling Verilog. You need to use the make files to make that happen. All right, so if you wanted to, let's start with poking into the make file. And the make file is something that is generated by the code that I write for you to let you compile and run different parts of your project. Okay, so notice here there's a help section, and then there's different things that you can do like compile and simulate and view. All right, so that's a poke inside of the make file, but if you really are just trying to get going, you can do the following thing. What you're going to need to do, if you're on a Mac, you go up to the top screen and you see the terminal menu option, and you're going to say new terminal. On a PC, I think the terminal option is somewhere up in here on the screen. So open up a terminal, and it takes a while for that to run, but you'll have an interactive terminal screen down here at this portion of VS Code. All right, so what I can do there is I can then type commands. All right, so the first one I would like you to take a look at is make help. And that tells me what to do to run different test functions on your modules. All right, so before we run test functions, let's open up a module and take a look. All right, so I go to RTL. Let's look at logic function 0. Okay, so I open that. I can minimize this. You can rearrange these, pull this down to where you don't see as much of the terminal. All right, I made the fonts bigger for this video, so hopefully are easier for you to see. Okay, in class we talked about how to define a module, and this is something I want you to focus on. In fact, that's part of the point of this lab, is you're going to replicate some of the functions, and that requires typing on your part, which I think is good. I don't want you to cut and paste from different places because you're trying to learn how to make a module from scratch. Okay, so to make a module from scratch, you start with the module keyword, then you give it a name, and then you give it the port definitions. All right, so that's the part in purple. And so we have, with port definitions, inputs and outputs. So I have single wire inputs, P, Q, R, and S, and an output F. All right, and so then there's a semicolon at the end to say that I'm done with the port definitions. All right, so module, name, port definitions. Then you put what you want the module to do. All right, so I have some comment files in here, and this is a very simple module. We're just assigning a logic function. All right, so that's all there is to it. All right, modules we'll do later will be more complicated. All right, so once you have that, you need to be able to test it. So it makes sense that you would go over here and look at test benches. All right, so we're going to look at the test bench for logic function 0. All right, so we'll go into more details later. Let me get the high points of the test bench. Okay, so test benches are also modules. So they'll say module and then test bench, but the difference is you immediately end with a semicolon. There is no port list. All right, so no parentheses, inputs, outputs, and all that kind of stuff. It's just a module that's a test bench, semicolon. All right, from there, you have reges. Reges, I'll give you some background reading, but reges are a way of assigning things to variables. Okay, you can't assign something directly to a wire. So with a test bench, typically the things that you use for inputs to test, right? So in this case, we're looking at inputs A, B, C, and D. All right, that's different than P, Q, R, and S. That's okay, I did that intentionally because I wanted to show you how instantiation works. All right, so we'll talk about this more, but this logic function that we're testing, the first thing you have to do is instantiate it, okay? And so we'll talk about this in class as well. But the way you instantiate is you look at the original module definition. So let's go back up here and do that. So that would be here. All right, so notice the inputs are P, Q, R, and S, and the output is F0. Okay, so going back to the test bench, the input dot P, the dot means I want to instantiate, I want to connect P to A. I want to connect Q to B. So instantiate the inputs and the outputs in the test bench. And from there, hitting the high points, you take all the input combinations, all right? So we're doing A, B, C, D is equal to, this is a way of assigning the values, all right? And then what's important also is this parameter, this #10, that says to delay 10 simulation ticks before you change the output. All right, so we're trying to control time so that we can make a test bench so we can see what's going to happen with the output of our systems. So the pound, that's an important thing. It tells how much time should elapse before I change the inputs. All right, so you see what I'm doing here is I'm changing the input combinations, going through all the combinations. After each combination, I delay 10 delay steps, and then I display the results. Okay, so it's pretty simple to do. All right, so from there, what I want you to do, you should follow along, is go back to the terminal. Okay, and so if you forget what to do, you say make help. All right, and I'm thinking, oh, I want to test the first function. Okay, so I only want to do that one, nothing else. So I can go and I can do make test dash func 0, just like the help says, and it will run the test bench and give the logic showing up on the output. Okay, so we can confirm that that works. All right, so the next thing that I want to do is point out that in the test bench, there's some commands here that look weird, all right? This dump file business, this is a way of capturing waveforms so that I can look at the waveform versions of test benches instead of the things that are going back to the screen. All right, so because we're doing hardware design, a lot of times we need to look at the actual voltage waveforms, all right? We want it to be a continuous function of time, not the discrete values that you get if you only look at samples in time, all right? So when I ran this, the waveforms got generated, and so I go to the waveforms part of the directory, and I can click on this, and it will bring me to a really rough previewer within VS Code. Okay. So from there, I can add signals. And so I have A. So double click A, B, C, and D. Those are the inputs. And then I have the output F. All right. So from there, I can hit this scale button, and that will let me take a look at that. And you can see I now have all the input combinations. You can drag this back and forth and scale this. Look at all the input combinations for this function and look at the outputs. All right, so that's an important thing to be able to look at the waveforms. All right, so what we've gone over is we've looked at RTL files, so I can say, I want to know what these files are. I can look at function F2, and it's got this set up for you. All right, and this is the module for function 2. All right, I'm actually going to give you a template that deletes some of this, and so you'll have to type it back in. All right, and the whole point of doing that is so that you learn how to make modules and get your practice in. Okay, so that's the main thing that I want you to know from this video.